This is a follow-up to my last video in which we defined a function as being a special relation in which all of our domain values go to one and only one at most output value. So what we're going to do in this video is just very quickly here determine whether an equation represents a function of x. And so I've got a couple of equations here, and what I give as instructions here is solve each equation for y and then determine whether the equation defines y as a function of x. So the first thing we'll always do to determine whether it's a function of x or y is a function of x is to isolate the y. So if I were to subtract 2x from both sides of this equation here, essentially we'd have y equals negative 2x plus 6. And I already identify this as being a slope-intercept form of a line, which is a function. But what I can see here is that every x value we plug into this relation here is going to pop out only one y value. And so I would say that yes, this is a function because it is 1 to 1. Is a 1-to-1 relation here, or every x value goes to one y value. Whereas the second relation here, if I were to subtract the x squared over to the right side here, we would end up with this statement here. We'd get y squared equals 1 minus x squared. And now I'll take the square root of both sides. Now the thing is, when we take the square root, we're responsible for putting a plus or minus in front. So what this means is, if I were to say, for instance here, plug in, I don't know, you pick your value for x here. Basically, you plug in a value for x and you take the square root of it. The thing is, we're going to get a positive y value and a negative y value. So this is not a function, and we can tell this because, while looking at the equation, we'll get two outputs for every one input that we throw into this. Cheers.